How self-driving cars work. For most of automotive history, driving has required a human behind the wheel making constant decisions, steering through traffic, watching for pedestrians, adjusting speed based on road conditions. But over the past decade, engineers have been working on a new type of vehicle that attempts to handle many of those decisions automatically. These are autonomous cars, sometimes called self-driving cars. Instead of relying entirely on a human driver, they use sensors, software, and artificial intelligence to interpret their surroundings and control the vehicle. The goal is to allow cars to navigate roads safely with minimal human input. So today, we are going to walk through how autonomous cars actually work and what technologies allow a vehicle to understand the road around it. Chapter 1. What autonomous driving means. Autonomous driving refers to a vehicle's ability to operate without direct human control. However, not all systems are fully autonomous. Most vehicles today use partial automation that assists the driver with tasks such as steering, braking, or maintaining speed. Engineers often describe levels of automation ranging from basic driver assistance to full self-driving capability. At lower levels, the driver remains responsible for most decisions. At higher levels, the vehicle's systems handle navigation and control on their own. Understanding these levels helps explain the current state of autonomous vehicle technology. Chapter 2. The sensors that see the road. Autonomous cars rely on several types of sensors to detect objects and understand their surroundings. One common sensor is a camera, which captures images similar to how human eyes observe the road. Another sensor is radar, which uses radio waves to measure the distance and speed of nearby objects. Some vehicles also use lidar, a technology that measures distances using pulses of laser light. Together, these sensors create a detailed picture of the environment around the car. This information helps the system detect vehicles, pedestrians, lane markings, and obstacles. Chapter 3. Sensor fusion. Because each sensor type has strengths and limitations, autonomous systems combine data from multiple sensors. This process is known as sensor fusion. For example, cameras may recognize traffic lights and road signs. Radar may detect the speed of vehicles ahead. LiDAR may provide precise measurements of nearby objects. By combining these data sources, the vehicle builds a more reliable understanding of the road environment. This layered view helps the system make safer decisions. Chapter 4. Mapping and localization. Autonomous vehicles often rely on detailed maps to understand where they are and where they are going. These maps contain precise information about road layouts, intersections, and lane positions. Using GPS and sensor data, the vehicle determines its location relative to these maps. This process is called localization. Accurate localization allows the car to align what it sees through its sensors with known features of the road network. Chapter 5. Perception and object detection. Once sensor data is collected, the system must interpret it. This stage is called perception. Artificial intelligence models analyze images and sensor data to identify objects around the vehicle. The system attempts to classify objects such as cars, cyclists, pedestrians, and traffic signs. It also tracks their movement and predicts how they might behave. This understanding helps the vehicle anticipate possible hazards. Chapter 6. Planning the next move. After interpreting its surroundings, the vehicle must decide what action to take. This step is called path planning. The system calculates possible routes and determines the safest and most efficient way to move through traffic. It considers factors such as road rules, nearby vehicles, and speed limits. The goal is to generate a driving plan that avoids obstacles while following traffic regulations. Chapter 7. Vehicle control systems. Once a plan is created, the car's control systems carry out the driving commands. These systems adjust steering, acceleration, and braking. The commands are executed through electronic control units connected to the vehicle's mechanical components. Because these adjustments happen frequently and precisely, the car can maintain smooth movement and respond quickly to changes in the environment. Chapter 8. Artificial intelligence and machine learning. Artificial intelligence plays a significant role in autonomous driving. Machine learning models are trained using large datasets containing images and driving scenarios. These models learn to recognize patterns such as road markings, traffic lights, and pedestrian movement. Over time, the systems improve their ability to interpret complex driving environments. However, engineers must carefully test these systems to ensure they behave reliably in different situations. Chapter 9. Challenges of autonomous driving. Despite major progress, autonomous driving remains a difficult engineering challenge. Road environments are unpredictable. Weather conditions, construction zones, and unusual traffic behavior can create situations that are difficult for automated systems to interpret. Ensuring safety in all possible conditions requires extensive testing and refinement. As a result, fully autonomous vehicles are still being developed and evaluated. To wrap up, autonomous cars rely on a combination of sensors, artificial intelligence, and control systems to navigate roads. Sensors such as cameras, radar, and lidar detect the surrounding environment. Sensor fusion combines this information into a detailed picture of nearby objects and road conditions. Mapping and localization help the vehicle determine its position. Artificial intelligence interprets the environment, while planning algorithms determine the best path forward. Finally, control systems execute steering, acceleration, and braking to follow that plan. Together, these technologies allow vehicles to move toward a future where driving tasks can be increasingly automated. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. Comment below what other topics you would like us to cover. See you in the next one.